All right, so I'm going to go over a couple of problems that I think are important from the lesson one practice. So these will correspond to the CCA or the quiz that you'll see on Friday. All right, the first one is a problem. It's got 4 parts to it. So you need to understand like what part of the function you're looking for to answer each question. The original description says an investment of $75,000 increases at a rate of 12.5% per year. You need to write an equation to model the investment after T years. So just pay attention to what it's describing. You're not doing anything different. You're just analyzing the problem. So you're analyzing the parts that you've been writing into a function. If you're writing an equation after T years, that means we don't know how many years yet for part A. So I'm going to write this function as A equals the population of 75,000 for our p-value. I said population, principal amount, sorry, we were just doing population. Our principal amount for p-value of 75,000. It's increasing at a rate of 12.5% per year. So I'm going to write this as 1 plus the rate of 0.125. Because it's per year, that means annual, over 1 raised to the power of 1 annual year times t, because we don't know how many years yet. So as of part A, we're just using t for time. So I can clean this up. I don't need to write a fraction over 1. So I can actually edit this part here, and I can just write it as 0.125 instead of writing it over 1, which is what I'm going to do. And same thing with the exponent, I can just raise it to the power of t. So this is your model for part A, or your equation for part A. Part B, what is the growth factor? So this just goes over, it was the first part of the note sheet, so that first example section on the note sheet, talking about exponential growth or decay. So recall that the general form, I'm just going to write this off to the side, is a times b to the power of x. Of course, many of the functions that we've been going over have looked much more complex than that. No matter what the function is, you can simplify your b value, and you can in this example. So if we were to simplify this part right here, we would have one single number. That's your b value. That's your growth factor. So in this example, the growth factor is specifically 1.125. And that would just be what I highlighted in orange added together. So 1 plus 0.125 would be equal to 1.125. That's your growth factor. You definitely need to know that for the CCA on Friday. Growth factor, right there. Now, part C says, what is the value of the investment after 18 years? Round to the nearest hundredth. So we are going to take our function from part A. We're going to bring this down. Now we're going to be substituting in 18 years. So we have a specific value at this point. When I substitute in 18 years, we have 75,000 for our starting amount, times 1 plus 0.125 raised to the power of 18. And if you type that into your calculator, you get approximately $624,894.45. Okay, and part D says, what is the value of the investment after 30 years? So we're still going to use our function found in part A, but now we're substituting in 30 years. When I type this into my calculator, I have 2,000,000, right? Yeah, 2,568,247.87. Okay, that's it for problem one, but I just want to go back here and review the different parts. And the reason why I'm doing this is because you definitely have a problem like this on Friday. So part A asks us to write an equation to model the investment after 2 years. Don't substitute anything in for time in part A. It's telling you T years. That means you don't have a year. So very careful. Be very careful on this problem. T years in part A. The reason why it's asking you to do this is to make sure you understand how to write the function, but also so you can use part A to answer part C and part D. Part B asks you to find the growth factor. The growth factor is your B value of the most simplified function. So part A is not as simplified as possible. Therefore, you have to add 1 plus 0.125. When you add that together, you get your single B value of 1.125. That's a growth factor. If it was less than 1, it would be called a decay factor. That's not the case here, but you might see something that asks for the decay factor. Part C is using the function we wrote in part A, but substituting in 18 years for the time. And part D is also using the function we found in part A, but substituting in 30 for 30 years for the time. Okay. Number 2. Yeah, I think we'll go over number 2. I think that one is important for Friday as well. So number 2 says that you are considering applying for your first credit card. Your parents are willing to co-sign, but they ask you to research different card options and their interest rates before you apply. The Amazon card details are listed below. If you do not pay the balance for 1 year, how much would you owe for every $1 you spend? Round to the nearest hundredth. So that's just asking you basically, like, if you don't pay your bill back for a year, how much is the interest on every single dollar that you are spending? Of course, I'm sure you'll spend more than $1, but it's all relative. So it's asking you to find it on $1. Okay. The Amazon card tells us that it's compounded daily and that it has a 14.9% interest rate. So we are going to use our function for the daily or compounded daily, which is P multiplied by 1 plus the rate over the number of times compounded raised to the number of times compounded times the time. It's the same equation we used in number 1, but because it's compounded daily, the n value is going to be 365. All right, off to the side, I'm going to list my values. The principal amount, the starting amount. We're asked to find this for every $1 we spend. So our principal amount in this example is 1. I know we haven't done anything with that low of a number, but that is what this says. So it says for every $1 you spend. The rate is 14.9%. If we were to convert this to a decimal, which we need to do, we have 0.149. And that's the rate that we are using. We already talked about the n value for compounded daily, which is 365. And then lastly, the time. So we're looking to find how much we would owe on that $1 after 1 year. When I substitute all these values into that equation, I have 1 multiplied by 1 plus 0.149 divided by 365 raised to the power of 365 times 1. When I type this into my calculator, I end up with approximately 1.16. That means for every $1 you spend and you don't pay back for a year, you're going to owe $1.16. So you owe an additional 16 cents on that $1 if this is the interest rate and it's compounded daily. Okay, could you change this function? Like say your credit card bill that you spent over the course of the year and you didn't pay back was $325. I mean, that's quite low probably compared to what you would spend, but just say it was $325. You would change in that case your principal amount to $325 and you would figure out how much you owe after 1 year. All right, option B says that it's a Disney card. The details are listed below. If you do not pay the balance back for 1 year, how much do you owe for every $1 spent? So very similar, but this card has some different details. This one is compounded continuously, so it's a different formula that we're using. And also, it has a different interest rate. It has an interest rate of 15.2%. So we're going to be using the equation. It's P multiplied by E, which is a key in your calculator. It's called the number E, raised to the power of the rate times the time. Okay, our principal amount, same as what it was above, it's 1. Our rate has changed to 15.2%. So as a decimal, this is 0.152. And for the time, we're still looking for 1 year. Substitute these values in. We have 1 times E raised to the power of 0.152 times 1. When you type this into your calculator, you also get $1.16. So we have the same answer twice, 2 different cards, 2 different types of compounding, 2 different interest rates, but they are giving you the same answer. That's completely normal. That's probably going to happen on your CCA as well. Or maybe it'll be like 1 cent different. There's going to be a question that's very similar. This happens a lot. In fact, like in real life, all credit cards do kind of have something different going on, but in the end, they're all very similar. So if you were to get 2 different credit cards, spend the same amount of money on them, obviously it's 2 different companies, so they're probably looking at something slightly different. At the end of the year, your interest that you owe on those 2 cards will be almost the same, even though it's something different happening. And this is the reason why. It's just whichever formula they use. If you pay your credit card bill off, then you wouldn't owe any interest. What other one? Okay, I wanted to go over number 4 right here. So number 4 says the population of East Greenwich, Rhode Island is 26,000 and it is currently decreasing by a rate of 5.1% each year. I did make this up, so this is not accurate numbers. So just so you know. The population of North Kingstown is 23,000 and is currently increasing by a rate of 4.5%. So write an equation to model the population of each town. So in this one, I have 2 different equations that I need to write. I have the East Greenwich population and I have the North Kingstown population. So let's start with East Greenwich. So for this one, it's a population problem. In either case, we're going to be using the formula A is equal to P multiplied by 1 plus or minus, but the standard form is plus. So plus R raised to the power of T. For the East Greenwich town, our population starts off at 26,000. It is decreasing by a rate of 5.1. If it's decreasing, then you're subtracting the amount from, or you're subtracting the rate. That would be because the population needs to get smaller. The only way for that to happen is with that subtraction sign. So that would be 0.051 for your rate. And then we haven't looked at years yet, so I'm just going to use a variable. I'm going to keep it as t, kind of like we did on that first example. We're just writing an equation to model it. At this point, we're not asked a question about time. So here's your equation for East Greenwich. 26,000 multiplied by 1 minus 0.051 raised to the power of t. Now for NK, using the same general formula, we're starting off with a population of 23,000. This population is increasing, so we use a plus sign. Our rate is going to be 0.045. And we still don't know the time for that one, so I'm using a variable of t for now. Okay, part B says create a table to represent the anticipated population over a 5-year period, if necessary. Round to the nearest whole number. Again, it's population of humans, so anytime you have the population of humans, you're going to round to a whole number person. So I need to fill in each of these tables. That means I need to keep my calculator going, and I need to just keep changing the year. For year 0, for East Greenwich, we use our equation that we wrote above. We substitute t equals 0 into the equation. So when we do that, when we substitute 0 in, that means we're starting with 26,000. That's your starting point at year 0. After 1 year, that means we're changing the t value of our function to 1. So in your calculator, you would type in 26,000 multiplied by 1 minus 0.051 raised to the power of 1, and your output will be 24,674. After 2 years, you would change your t value to 2. So type in the same function, change that exponent to 2. Your output is 23,416. After 3 years, the population decreases to 22,221. After 4 years, we're at 21,088. And after 5 years, you're at 20,013. So all I did was just alter my t value for each one of those functions. I'm going to do the same thing for the North Kingstown population. So year 0 is your starting point. That means your t value is 0. When you type that into your calculator, your output is 23,000. That's where you start with, or that's the starting population. After 1 year, changing your t value to 1 will change the population to 24,035. After 2 years, the population is 25,117. 3 years, 26,247. 4 years, 27,428. After 5 years, 28,662. So we just found the population for each town over the course of a 5-year period. One of the towns is decreasing, one of the towns is increasing. Part C says, using the table from Part B, approximately how many years will it take for the population of North Kingstown to be greater than the population of East Greenwich? So let's just look at our tables and compare. At year 0, the population of East Greenwich is more. We're at 26,000. After 1 year, the population of East Greenwich is still more. East Greenwich has 24,674 people. North Kingstown has 24,335 people. But after 2 years, somewhere between the first and second year of this table here, so of the population increase and decrease, the East Greenwich population goes below the North Kingstown population. The East Greenwich population after 2 years is 23,000. North Kingstown population is 25,000. So approximately how many years will it take for the population of North Kingstown to be greater? I'm going to say after 2 years. It's approximately. It happens somewhere between 1 and 2 years, but just round to the nearest number on your table, make it easy. It's after 2 years. You guys all see that? Okay, so I'm just comparing, looking at my values. They're right next to each other, so should be helpful. And then the last question just says, what is the anticipated population in each town after 7 years? Round to the nearest whole number. That's not on your table, so you're going to have to do that in your calculators. Check for East Greenwich. The East Greenwich population after 7 years, use your equation, change the year to 7. It's at 18,023 people. And 7 years for North Kingstown would be 31,300 people. Okay. There's going to be a problem like number 5 on your CCA as well. So I'm just going to go over one of the options because they're all very similar. So if you can see how I do one of them, you should be good for the CCA on Friday. Number 5 says you're investing $25,000 in a new bank account. The banker presents you with 4 investment options. All of them are interest earning accounts. How much money will you have in the account, and what is the total interest earned after 4 years? Calculate each option. So let's do option 2 just because we haven't done any compounded monthly yet. So if we're compounding monthly, that means the n value for our function is 12. It also tells us that I'm using the function p multiplied by 1 plus the rate over the number of times compounded multiplied by number of times compounded times time. When I substitute these into my equation, substitute in anything that you know. So we know that the starting amount, the amount that you're investing is $2,500. I know that from this part up here. I have 1 plus. I know that the rate is given to me as 1.5%, which converted to a decimal would be 0.015. I know the number of times this is compounded is 12 because it's compounded monthly. Same thing for the exponent value of n. And then for time, it does say, or it indicates we're looking to see how much you earn in your account after 4 years. So the time is 4. If we type this into our calculator, the balance in our account after 4 years is going to be approximately $2,654.49. So that's how much you would have total. That would be your starting amount of $2,500 plus all the interest you earned. So this part is what I want to just make a note of so you're prepared for that. What is the interest earned? So what is the difference? We have $2,654.49 minus $2,500, which was the starting point. So this is an extra amount of interest, which is $154.49. This here is the amount of interest you earned over those 4 years. Okay, for a problem like this, you would repeat this for all of your options. So you're changing the compounded amount for each problem. You're changing your annual interest rate, but you're still completing it the same way. So I don't think I need to go through all 4 of them. They're very similar. But the question at the bottom says, in which case, we didn't do them all, but which investment option would yield you a greater profit? So the problem's asking you to look at all your options here and pick the one that's going to earn you the most amount of money. So if you were to complete this by yourself, it's option 1 that earns you the most amount of money. I know we didn't do that one, but that would be the best bet or the most amount of money that you could earn.